Welcome to Always Eclectic Stacy. This is 5-minute chemistry where you learn chemistry concepts and examples in 5 minutes or less. Today we're talking about the different ways of modeling covalent compounds, and this is diarsenic trioxide. Let's get modeling. Today we're going to model diarsenic trioxide in 3 different ways. Now remember, the first step is to go ahead and draw your Lewis dots. So I'm going to draw arsenic first. And it is in column 15, so it does have 5 valence electrons. Remembering valence electrons are those electrons in those outermost orbitals. And I drew 2 arsenics because there's 2 next to the arsenic, which means there's 2 arsenics in the compound. Now for oxygen, remembering it is in column 16, so it has 6 valence electrons. I'm going to draw 3 of them because the 3 is next to the oxygen, and that means that there are 3 oxygens. And again, remember, valence electrons are those electrons in the outermost orbitals. Let's also remember that the golden rule is the octet rule, which basically says all elements tend to gain, share, or lose electrons to try to get to 8, which really means they're all trying to mimic noble gases. So that is what they're going to do today. Now, arsenic are going to be the stars of the show because it has 1, 2, 3 bonding potential as shown by the 3 lone dots here, which means it needs 1, 2, 3 more. And although oxygen is important, it has 1, 2 potentials, and so it's not going to be as important as arsenic. Now, a lot of people go, how do I even start? And I say, when you have 1, 2, 3 of the not stars and 2 of the stars, you kind of put the 2 stars starting in the middle, but not right next to each other. So I'm going to put an arsenic here. I'm going to put an arsenic here. Now we have 3 oxygens, and everyone goes, I'm so worried about how you're going to do it. You can go do it in a line. You can do it as an M. It doesn't matter. But the idea is you're going to alternate oxygen and arsenic. So you have an oxygen here. I'm going to do it down below so you can see how it all works. Here. Now, before we get further in, please don't forget to go ahead and put in those solid pairs where they need to be. So 1, 2, 1, 2 for arsenic, because arsenic has 3 bonding potentials, but it has this bonded pair right here. And oxygen has 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. Each oxygen has 2 pairs of electrons that are already bonded. Now, you ask yourself, how do I start? Well, we know each oxygen needs a double bond, or 2 bonds. It could be a double or 2 singles, and we know each arsenic makes 3. So you start from the outside and you work your way in. So we know this oxygen must double bond with this arsenic, and we know this oxygen must double bond with this arsenic. It fulfills this oxygen, and this oxygen is fulfilled. Now this oxygen isn't, and you're going, what about that poor oxygen? Well, remember, each arsenic needs 3, and each oxygen needs 2. So the one in the middle will bond 1 time each with the arsenic. So now we can count 1, 2, 3, 4. So it has 4 bonds. So it's 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everything is super happy. Arsenics and oxygens are happy. Now we can do this exact same item, the exact same way, but this time we're not going to draw our bonds. We're going to draw the Lewis dot. And I'm going to draw it because we know where those dots are going to go. And we're drawing this Lewis dot to show that, yes, oxygen had 6 ones to share. It had 4 that couldn't be shared. It had 2 that could share. This one looked like that. This one, again, it has 2 completely bonded pairs, but it needs 8. So it needs to share the 2 that aren't bonded to get to 8. So this arsenic shares 2, this oxygen shares 2, and it's going to be your double bond right there because it's each sharing 2. This is a single bond, and you can count that arsenic has 1, 2, 3 bonds, and this oxygen has 2, which matches. And you're going to go ahead and keep circling those. And then you can see where it all is. Okay, now we're going to go ahead and do this with the Bohr models. I've already set up all the Bohr models, so all that is missing are the ones in the center. So remember, you want 8 electrons in the outermost ring. And that includes whatever you're putting in the shared ring. So remember, each arsenic has 3 that it can share. I don't know why I was counting wrong. So there should be 1 bonded pair in each one, and then 3 it can share. So we're going to go ahead and do arsenic first, because we can look at the oxygen and go, okay, this oxygen has 2 it can share. These are those 2 lone pairs. So it needs to put both here. This oxygen has 2 it can share, and it's bonded to 2 separate things. So we're going to go ahead and put 1 in each ring. And then this oxygen has 2 it can share, so it's going to put 2 there. Now, the big rule with sharing is that if this shares 2, this also shares 2. So 1, 2, 3 is the amount it can share. So R6 is going to share 2 here, 1 here, 1 here, 2 here. So you can count 1, 2, 3, 4, 6, 8. 2, 4, 6, 8, because both bonds count as a shared. 2, 4, 6, 8, 4, 8. Everyone has a full octet on the outer orbital. Thank you so much for watching. If you like this video, please do not forget to like and subscribe, and check out my other videos. Thank you so much. Have a great day.